Hey there, AP Pre-Calc homies, or whatever I'll call you, we'll figure it out. Alright, today we're going to be looking at Lesson 3A, Rates of Change, Linear and Quadratic Functions. Previously we talked about finding the average rate of change by looking at graphs and tables and functions. Now we're going to apply it to linear and quadratics. We've already kind of done this, but we're going to expand upon it. Alright? So, we've done some secant line stuff, but now we're going to name it. Alright? So a secant line is a line that connects 2 points on a function. Find the slope, we do the change in y over the change in x. Okay? Which we know change in y is the same thing as f of your y, or f of your x minus f of your other x, so f of a minus, or f of b minus f of a. And then on the bottom we have our change in x. So this isn't really new. It's our slope, it's our average rate of change, it's our slope of our secant line. Alright? So let's do an example and see what this crazy guy is talking about. Alright? So, oopsie. Consider the equation at the right. It passes through those points. And how do you know it's the equation of y equals 3/2 x minus 3? Well, we know it is because -3 is the y-intercept, right? And I can look at that from the graph. That's from my good old mx plus b, right? Where b is your y-intercept, m is your slope. So my 3/2, I go up 1, 2, 3 over 2. So I do delta y is 3, delta x is 2. So my slope is 3 over 2. That's how I know that's the equation. Does that kind of ring a bell from back in the days? So what's the average rate of change for a linear function? My average rate of change is going to be equal to my slope of a linear function. Okay? My slope is my average rate of change if my function is just a linear one, because slope gives me a lot. Now, next question. How is the average rate of change related to itself? So, average rate of change relates to the equation for every one increase in x, y increases 3/2. So if x goes up 1, y goes up 3/2. If you took AP Stats, this might look kind of familiar. Okay. Alright, let's look at D. Let's sketch a graph of a function that represents average rate of change of the linear function. Alright, so think about this. My average rate of change of that linear function is 3/2, correct? So, what's my average rate of change on this graph at any point? At any point I grab it, what's the slope? It's 3/2 here, it's 3/2 here, it's 3/2 here. So because this is a linear equation, linear equations have constant change. So the change never changes. Alright, what's that even mean? Well, what it means is when I graph this, if at point 0 my slope is 3/2, because I'm graphing the slope. I'm graphing the A-rock here. At 1 my slope is 3/2. At 2 my slope is 3/2. At all these points my slope is 3/2. It is constant. It is a flat line. My rate of change does not change, unlike a parabola or another type of function, right? All right, let's get more into it. Let's do example 2. So we have a quadratic. We graphed it at the right. Now we want to see, what does the rate of change do here? What happens? Who knows? I'll let you know. So from 0 to 1, when I go from 0 to 1, from here to here, my slope of that line is -5. Okay? That slope is -5. From 1 to 2, this line, that slope is -3. And we do that by doing our change in y over change in x, right? My slope from 2 to 3 is -1. Do you see how those slopes are getting less and less intense down? They're getting more and more positive. They're increasing. That's what makes a concave up, right? From 3 to 4, it starts going the opposite direction, right? We have 1, 3, 5. They're the same in reverse. So again, that's my slope on that interval. So between those 2 points. But what I want you to notice, my slopes, my average rate of change aren't constant, but this went up by 2. It went up +2. Between these 2 intervals, my slope went up +2. Slope went up +2. Slope went up +2. And my slope went up +2. So the slope of my change in slope is 2. What do you think will happen? What do you think the rate of change? What is the rate of change at 3? Oh, do you notice a pattern? Yes, it goes +2 every interval, right? Now, do I notice a pattern at 3? Well, at 3, my slope is 0. The A rock is 0, right? Because my tangent at that point is a flat line. So that would make, it's 0 good because my tangent has 0 slope. Okay? All right. This will give us a start on this one at least. I hope you enjoyed. Bring in questions. Have a great day.